Hi, you're officially welcome to another PLD session. In today's session, we are discussing data structures in Python. In the previous session, we already discussed one type of data structure in Python, which is list, and today we are trying to finish up with the other built-in data structures that are available to us in Python, which are tuples, dictionaries, and sets. So, from our last session, which I have a script here, we started by trying to understand some of the terminologies that are used to describe these various data structures. So just a quick run through of them. We mentioned that the data that we have in the collection. So these data structures that we are talking about, we said they are basically a collection of data. Okay, so these data that were collected together could be heterogeneous, meaning there are a mixture of data types. There are data of different types could be put together. Could be homogeneous, meaning they are the same data type, the collection of the same data type. We could have the collection being mutable. And mutable basically means that we can change them. Okay, so I mentioned some actions or some operations that can be done on collections that are mutable. That is, we could add, we could update, we could change, delete elements of the collection. Then when we say some are immutable means that we can't do any of the actions that I mentioned earlier. So we can't change anything. Indexable, we can reach the various elements of the collection by using some form of index. Okay, and ordered means they are the order of appearance in that collection is of importance. So the item that is at position 1 must always be at position 1. And that is when we will say something is ordered. So as we talk about the different types of data structures, we are going to still find ourselves using or coming across those words a lot. So let's start by discussing what tuples are. Tuples basically are, just as I've already said, so they are, let's say, a collection, all right? I've already mentioned that these data structures are a way for us to put together a number of data together. So each of them is a collection, but a collection of what? That's what we should be looking at, and how different is one data type from the other. So when you take a tuple basically is a collection of data of different types, just as we have in lists, but for tuples in particular, the data is immutable. So I already explained those terminologies. So a collection of data which is immutable. Okay, they are immutable, meaning that that collection of data cannot be changed. They cannot be directly updated like that. So if you have, say, some form of data that you want to store in your application that you are building, such that you don't want anyone to be able to make changes to the data that you have put together. Okay, so for instance, let's say you have decided to record a score of a particular student. Okay, so the scores of a particular student, say the student scored 80 in one subject, 75 in another subject, 56 in another, and you score 20 in the last subject. You want to store this data in your application and probably use it for whatever purposes. Or there is a big application where you are able to store multiple students' information, but then you want to make sure that when you store their scores, the students' scores, they are not able to update it or they are not able to change it. Then here we should start thinking about a collection of data that is immutable, so that as soon as I put them together for whatever operations that I'm going to be doing, no students can, no one can come and change them. It is not allowed. Okay, so that's basically what tuples are. Then aside being immutable, we should also know that they are I mean, I would want to not necessarily define, but let me mention some of the features. The words that are described up there, so they are also heterogeneous, and I've already explained what heterogeneous means. They are ordered as well, okay? Ordered, so the order is very important. Then they are also indexable. At the end of the day, we are going to try our best to differentiate tuples from the various other data types, okay, especially lists, because it is closely related to list, or it looks just like a list. But then there are some differences. So from our definition, we'll go back and try and compare them. Now we know that tuples, when we take tuples, a collection of data, they are immutable when we put them together. They are heterogeneous, meaning we can put different data types together. They are ordered, okay, meaning the position of each item matters. So for instance, if you take this particular list, I'm using list literally, but then I mean this collection, let me use collection. This collection of data that I have here, this is at position 1. Maybe I know in my mind that position 1, I use it to record subject A. I use position 2 to record subject B. I use position 3 to record subject C. I use position 4 to record subject D. So if you go about to move any of these in terms of moving their positions, okay, changing their positions, then that would be a problem. But the good thing about tuples is that they are ordered, and therefore, and in fact, they are even immutable. So it's not allowed for someone to move them like that. So the order in which they appear is very important. They are indexable. If you were here for the last section, or if you have been with us throughout this various sessions that we've been doing, we've talked about how we use index to access data, especially when we're talking about strings, and even when we're talking about lists too. So we can basically use the index to access the members of a tuple. But then how do we create a tuple in Python? That's one thing that we need to know. To create a list, just to refresh our memory, to create a list, all we needed was what? A square bracket to create a list. Then whatever collection of data will be inside this square bracket. To create a tuple, on the other hand, we use the parentheses. So basically, you would say you have a tuple, meaning, I think last time I mentioned that all of these collections helping you just give one variable name to a number of data. Okay, so let's assume that these are the scores of a student that I want to use. So I can say that the score, right, go here, the score or scores is equal to, if I want to have it stored as tuple, then I will have it as such. So we'll go ahead and enter the data 80, 75, 56, 20. Okay, let me leave some spaces in there. Space it out. Okay, good. So basically, by putting this inside parentheses, that makes it a tuple. So if I had written it this way, let me rewrite this. If I had written it this way and put it inside the square bracket, then you will say I'm creating a list. So that is the basic difference between a list and a tuple. In a list, we are using a square bracket. So let me put, this is, sorry, this, I think the size is too big, but then, size. Wait, oh, that's the smallest. Okay, so this is lists, then this is tuple. So basically, the fact that I put this in a parenthesis, whilst I put this in a square bracket, differentiates them. And I'll explain that the major difference between the list and the lists. Oh, my network isn't. Hi, can you hear me? Can you hear me?
Yes, we can hear you, Doctor.
Okay, great. So kindly let me know when you can't hear me because today my network isn't stable. Okay, thank you. So I was going to say something. Okay, I can't even remember what I was going. But then, what I'm saying, okay, great, I remember. So we could equally store these scores of students as either lists or tuples. But then you have to know how are you going to use the data. If your interest is just to have access to the data and manipulate it anyhow you want, at the end of the day, you may want to add on. I think during our list discussion, we took a set of scores and we added on based on the students' performance. If you are going to be doing anything of that sort, then you should stick with list. But if you want to such that nothing should be able to change the scores of each student, then you are going to store it as tuples. So that is one practical use of tuples. You store a data in a way that nothing should be able to change them. So for instance, if I have a collection of, let's say, bank accounts, okay, bank account numbers. If you have bank account numbers, I believe a collection of such, you wouldn't want someone to be able to, out of the blue, come and change them, okay? So let me say my customer's account. So B underscore account is the name, is equal to, if I want to store their account, I could use lists just as we have explained. Maybe this is 0442, something of this sort, then followed by the next person, 044, okay, something like that. Okay, but then now you know that anybody at all, I mean, along the line, you may do an operation that may end up changing the customer's account number, which is not good because you don't want to change anybody's account number. An account number is supposed to be fixed and protected. So if you want to give it that privilege of right protection, you would rather go and create this account number as what? A tuple. And the only difference is that you use the parentheses instead of the square bracket and put in whatever data you're going to put in. Separate the individual data with a comma. So that's basically how we create tuples. But then an interesting thing about tuples is that, in fact, even when you write tuples when you write data that are separated with commas without the parentheses, they still are tuples. So tuples, let's say back to our scores where we had this. Initially, I wrote them as 80, 75, 56, 20. So 80, 75, 56, 20. This also represents a tuple. So pay particular attention to that. Some of you will start wondering, I know when we want to declare a variable, it's just the name of the variable is equal to just one data. But in this case, we have multiple data. So what are we actually doing? And this you can do in some programming languages. So in Python, an expression like is seen as a tuple. Once you have scores is equal to this comma that, once you have anything of that sort, is seen as what? A tuple. Then the question arises, what if my tuple has just one element? Okay, so if let's say my tuple was, say, just a score, and score was equal to the person who got 95. If I leave it this way, score is equal to 95, you know by now that this will just assign 95 as a value to score. So we are just declaring what? A variable. This will just be declaring a variable and not a tuple. I hope we can see that. If we just write score is equal to 95, it's going to say just as a variable. In the same way, we can't also do this and think that is a tuple. No. So anytime that you want to create a tuple with just one member, one important thing you need to pay attention to is the comma. Very important. So even though you have just one member in that collection, sorry, it should be equal to, even though you have just one member in that collection, you have to add the comma to indicate that you're writing a tuple. So this particular score up here, I could change that to a tuple just by doing this is equal to 95 comma. So this becomes a tuple with one word element. That's basically what it is. A tuple with one element is when you have the elements then comma. Okay, but if you put it in parentheses to the same thing, then the other thing that we should look at is how then do we declare an empty tuple? An empty tuple. How will you declare an empty tuple? So assuming the scores is actually empty. In fact, I don't know the practical use of an empty tuple, but then it is something we need to be aware of. So if score is actually empty, are you saying I could leave it like this? Since the notation, we said that you can write this and without the parentheses, it becomes what? A tuple. And we've also written this. So how do I go about it? To write an empty tuple. So the notation for an empty tuple is the parentheses. Okay, just write score is equal to parentheses with nothing in it. Then you have created an empty tuple. So always pay attention to these things. At the end of the day, knowing that this is a tuple, I mean this particular part. Sorry, this particular part. Knowing that this is a tuple is going to help you a lot. And by the time we are done, I'll show you something that will prove what I mean by this. Okay, so pay particular attention. If you see multiple data being assigned to a single thing, most commonly it is a tuple that we are working with. Any questions so far? Once we know how to create, if you have a question, you can unmute and ask the question. Going on, once we have been able to create a tuple, then we want to be able to access the members of the tuple. So this score that we have, the scores that we have collected together in a tuple, okay, how do we access, assuming I want that score at this position, say at 75. So now I'm talking about how you assess the members of a tuple. Okay, so our tuple of interest is false, which is equal to, let me probably put it in the parentheses so that at least it always draws your mind that this is a tuple. Okay. To access the members of a tuple, what we can use is indexing. So we can use indexing as we did with strings and lists. We can do the same thing here. So if I want the very first one, we should remember that indexing starts from index 0. So this particular one is 0. This one is 1. This one is 2, and this is 3. So if I want the score at index 1, all that I have to do is write the name of the variable, okay? The name of the variable, in this case, the variable is score. So the name of the variable square, and in the square bracket, then the index that you are looking for. So if you do scores and square bracket 1, it means you are trying to access the elements at index 1. We can do that for every one of them and access each and every member of that particular tuple. In the same way, we have already learned about negative indexing. Where negative indexing basically is when you have a collection of data that is indexable. When you start indexing them from behind, the very last element is always index -1. Then coming forward, we have index -2, index -3, index -4. So in that order, if I go ahead and I type scores of index -3, then you should know the exact value I am looking for. This 75 will be index what -3. So that is what will be returned to me. So way. So apart from the positive indexing, we can also get access to the data using negative indexing. Then aside indexing, we have also discussed what we call slicing. During our lesson on list, still talked about it, slicing. And slicing is basically using the index to get a range of data within a collection. So for now that we have scores, there are 4 scores there. Assuming I want the 2 in the middle, that means I don't want everything. I'm just interested in the 2 in the middle, or I'm interested in the first 2 elements in this tuple. So I can use slicing to get there. And slicing basically, you write it in this form. So the name of the variable that you created for the tuple, I mean the name of the tuple, I should be saying that instead of saying variable. Then where you are starting from, okay, so where are you starting from? Then column, where do you want to end? Then column, the step, okay? So step means like, are you trying to jump any of them? How many times should I jump? All right, so if I have, say, this 80, 75, 56, and 20. Okay, if I'm starting, this is in the 0, in this 1, in this 2, in this 3. So if I say start at 0 and end at 3, yes. So another important thing to note about slicing is the end is exclusive. So when it starts counting, it doesn't include a specific index at end. So now that you have 3, it means whatever value is at index 3 will not be returned. So you have up to what is before index 3. So it's exclusive of index 3. That means in this our case, if we have scores and we have 0 to 3. Okay, by default, once we don't bring the step, by default, the step is 1. So we'll be moving 1 at a time, like 1 item at a time. So we have from 0 to 1, then from 1 to 2. Then from 2, you are supposed to go to 3. But remember that index 3 is what? Exclusive, because you chose it as the end. So this, as we have here, is going to return 80, 75, and 56. I hope that makes sense. So that is one way that we can access the members. But then if you are specifically starting from 0, you can always leave the start, bring your column and add the end, okay, where you are ending. If you are looking for something, let's say I'm starting at 2, but I'm ending at the last element. I mean, the last element is inclusive, then you have to leave this as such. Don't write anything here. So if I start 0, no, sorry, 2 this, it means I want from index 2 to the end. But if I do something of this sort, it means I want everything, okay? So from the very beginning to the very end, that is how we use slicing to access them. Last week, I mean, during our last meeting, I explained how we can use slicing to reverse a list. So your assignment is to try using slicing to reverse a tuple. If you are given a tuple, try using slicing to reverse it and see. That is your assignment. I mean, go and try it by yourself. Okay, so once we know that these ways, we can use these ways to access the members of a tuple. Now let's look at some of the things that we can do with a tuple, because all of these things that I've shown you right now, we can do them with a list. So it's basically the same thing that we have been learning. We've learned how to do this with a list, and now we've learned how to do it with a tuple. So what are some of the things that we could do with a list that we can't do with a tuple? And that is the very things that make tuples different from lists. Okay, so one of the first things that we should know is that in lists we're able to append to a list. So if right now, after writing the scores of the students, after writing the scores, say we already wrote the scores, which is equal to 80, 75, 56, and 20. We've already written it. But let's say I just remember that, oh, I left this guy's one of the scores out. The last subject that he did, I didn't record the score. So the normal thing that I would think about is, oh, let me just clean this and append that score to it. But this is a no-no in tuples. So when we're starting, I said that there are use cases. If you think something of this sort will come up, such that you would have to come and update it, then using a tuple is not the right thing. If it was a list, we could have just gone ahead to append this extra data to our list. But then this is a tuple, it has rights protection. Once it is created, we can add to it. Very, very important. Okay, so if you are choosing the data type for the data that you are going to be working with, you have to ask yourself all these questions. In the near future or along the line as you are building your program, is there a chance that you are going to add on elements to your collection of data? If there is no chance, zero chance that you are going to add an element, and if there is zero chance that you are going to need to update anything, then using the tuple is the best option. And then if there is a little chance that you are going to update or add on or append some data to the collection, then using a list will be the best option. In the same way that we can't add on to this particular list, this particular tuple, we can't also, so I said we can't add is a no. We can't also delete an element. Delete an element. Please pay attention to my choice of words here. We can't delete an element in a tuple. Okay, what do I mean? If let's say this 80 we wrote here was a mistake, so we need to get rid of it. It was actually 89 that we were going to add, and we couldn't add the 80 now. We've already written 80 here. We need to delete it. No. Because you stored it as a tuple, you can't delete it. Very, very important. You can't add, you can't delete. However, if I think that this whole thing is erroneous and I want to get rid of it, then I can delete the whole tuple. Remember that a tuple is basically like a variable that you have created to store multiple data, but those data cannot be updated. That's basically it. So if you want to delete that variable that you have created, in this case, the variable is called scores. If you want to delete scores, you are allowed to delete scores. That means that it's going to delete everything. You will no longer have scores available in your namespace. I mean, when you search for when you type anything or you want to do anything with scores, it's going to give you an error that this name is not defined. Okay, so that is why I wrote it as delete an element in a tuple. That is not possible. But then you can delete the whole tuple. Delete the tuple. Forgive the spelling. So you can delete the tuple, but you can't delete the individual elements in the tuple. I hope that makes sense. The last thing that I need to point out that you can't do is that if it's a tuple, you can't reassign. So all of these that I mentioned were things that you could do with lists. With lists, you could append through array. If you check the last lesson we had, I started by talking about how we add. I taught a number of methods that could be used to add to a list. I talked about deleting. I talked about a number of methods that could be used to delete. But here they are no. Then reassigning elements to in list we could reassign elements, but here we can't reassign elements. So even though we have index, say I could have just said scores of index 0 is equal to 89. If this was a list, if scores was a list, this would have worked. But since it's a tuple, we are going to get an error because we can't reassign whatever we have put at index 0. So basically, a tuple is like I have sealed it, like I've collected data, put it in a container, and sealed the data. All you can do is look at it. What is in there? Okay, so if you want, there is a score 80 in there at position 1. Whatever you want to use it for, go and use it for. But then you can't come and say, no, let me change 80. You are no longer 80. You have to become 81. No, that's not possible. Okay, so these are very important things that we need to know. Then when we're talking about list, I also talked about some other functions. I talked about, for instance, the len function, which helps us get the size of the list. So we can use the same to get a size of the tuple. So how many elements are in the tuple? You can use len to get it. Let me bring up my virtual machine so that we can get into the terminal and start writing some code. But if you have any questions, you can go ahead and ask your questions. Okay, so during the session on list 2, I said my interest was to teach you how you can learn to use some of these things up. So especially with the methods, I showed you how to get the various methods that are available or to use on the list. And the same thing applies to all the data sets that we'll be talking about. So I'm not going to spend a lot of time just like I did the last time trying to explain to you each method and how it works, because I believe now you should know how to access these various methods and what they are used for. I'm going to show it again how we get that, but then I'm not going to take each method and explain to you, okay, because we need to finish everything. Okay, good. Video. CD Python program CD Python. Okay, good. And code All right, so I'm trying to learn VS Code where we'll be using to write the code. For now, let's use the terminal. Still loading. Hurry up, hurry up. Okay. Right. Great. So let's bring out the interactive mode of Python. Then here we can go ahead and create this scores that we contain 80. I don't remember the rest. So let me just go ahead and add any set of numbers. Okay. So by doing this, we've been able to create a tuple. And if we check the type of scores, it should tell us that we are using a tuple. Oh, why did I type that? Type of scores. I mean type scores. So as you can see here, it's what class tuple. So basically, this is how we did here, helped us create a tuple called scores. And we've learned that we can access the members of a tuple using the index. So here, index 0 is the very first one, which is 80. Okay, we've also learned about slicing, where I said we could do this to get some sets. So we have 80, 56, and 87. So everything for index 3. This is index 0, index 1, index 2. So that is what is shown to us here. And in list, we could have done this to delete whatever is at index 0. We could have done delete to delete it, but then we can't do save. It says tuple objects doesn't support item deletion. Okay, so that is what I said earlier. Let me create another tuple called VV and set it to 1 and 2, just to show you that we can delete VV. So now if I type VV, it's going to give me 1, 2. But if I type delete VV, so when I explained that we can actually not delete the element of a tuple, but we can delete the whole tuple. So what I meant by that is if I run VV at index 0, I get a type error. But then if I run delete of VV, it deletes successfully. So now if I type VV, it says that name error, name VV is not defined. I hope that explains it. I mean, it brings out the meaning. So if you want to delete an item within a tuple, that's not allowed. But if you want to delete the whole tuple, that is allowed. And what brought us here was the length function, length, to get the size or how many elements are in the tuple that we have created. So when we run it, it gives us 4, and if you remember, there are 4 items in the tuple that we created. There's 1, 2, 3, and 4. There are 4 elements in there. So that is what this function helps us get. Another thing that we can do with tuples, and this is a tricky one, a number of times people get confused about it, is that say we have, let me create another tuple. Say my score is equal to 34, then 23. Okay, then I come and do scores plus my underscore score. See what has happened here. So already I've explained that you can't append onto a tuple. Okay, and that basically means that you can't add on to a tuple. But here is the case where I have this tuple 80, 56, 87, 40. Then I've been able to extend that with this tuple 34, 23. So now I have the whole thing inside one tuple. Okay, so a lot of people become confused with this, especially if I write something like scores is equal to scores, then I do a class, then I put maybe 67, 90, like this. Okay, then now when you come and say scores, now it looks as if you have appended some numbers to the tuple. Meanwhile, we've already established that a tuple is not, it's immutable, so you can't append data to it. So what is going on here? And that is where it becomes a difficult. But then the simple answer is that what we have done here with this, the concatenation sign, what we've done with it is basically we are creating a new tuple by combining multiple tuples. Okay, so it is not the old one that we are appending data to. No, we are creating a new tuple. We are just taking multiple tuples, putting them together to create a new tuple. We happen to have called that new tuple scores. So this scores here is a different object from this scores here. All you have done is you took this scores, then you added a new set, you concatenated a new set of tuples or a new tuple to it. So basically that's the explanation. You can't append to a tuple. If you want to try that, then the best you can do is concatenate another tuple to it. Okay, and generate it aside. So for instance, if I wanted to add 67 and 90 to this, all I have to do is to create a new scores variable or tuple, then assign it to the result or the outcome of the concatenation. So if you see that anywhere, you should understand why it is so and why we still maintain that you can't append to a tuple. Then, just as we're able to access elements in tuples and manipulate or use the data for things that we wanted to do, we can equally do same, using a loop. We can equally do same in tuples. Okay, so we could use a for loop to get the members of a tuple. Maybe we should try that. We have three things to talk about. I think I have to hurry up. So let's try scores underscore tuples dot py. Then here user Python 3. Okay. Then what we are going to do, we need the scores in the form of a tuple. We have 80, 76, say 32, 90. Okay, so if these are the scores that a person got, assuming we want to print each of them, okay, we want to print each of them, how do we go about it? We can use a for loop here using the membership operator. So in, we can use the in keyword to get any of them. So for instance, we can say score in scores. What this basically means is that for each item here, we want to do something to it. So we are calling each member a score. You can call it anything. Mostly you see for I in this, okay, but usually I prefer it to be like, it should make sense so that when you're writing a program, you don't end up getting confused. If you end up using I in almost every part of your loops, then you begin to wonder, what is this I representing? What is that I representing? What is that I representing? But then if you use something like this for score in scores, then you know that this value that we're getting is a single value coming from this tuple that we had here. Okay, so for score in score, for now, let's just go ahead and just print score. Okay, print score. Okay, good. So if I save this, then okay, let's make it executable. The name is scores. Okay, good. Then now let's run it. Scores. Okay, so as you can see, we've been able to print out each of the members. It is 76, 32, 90. This is the beauty of programming. Okay, some of us, maybe it is your first time you're learning about some of these things, so you can't envisage how this is going to become useful. But then, with the help of something like this, like a loop, for instance, we are able to do almost anything we want to do with this particular max. So you can have a program logic doing a whole lot of things, but your goal is that you should be able to access each member for a particular thing that you are going to do. So last time when we were working with list, we tried going to check each member here to see if it was below 90 and adding a particular element or a particular score to it. But then for now, we know we can't do that with tuples because tuples are immutable. We can't add onto them. We can only get them and use them for whatever. So if I want to add, see, when I say we can't add to them, it doesn't necessarily mean I can't add after I've gotten this, like score. After I've gotten it, I'm at liberty to add whatever I want to add to it. But then it doesn't affect the original thing here. Okay, so the final output could be like score plus 50. Then you are doing your operation. Now nobody cares. But what we are saying is that you can't edit the data here. You can't update this 80. Okay, so you can now come and say that for score is score, this score is equal to that score plus 10. Unless if you are creating a new one. Otherwise, it will not work. Okay, so after that is said, let me quickly bring up one thing. That is like one, can I say practical here? Yeah, practical application of tuples that you might not have thought about. Okay, or maybe actually, let me use this. Create a script, call it swap underscore tuples dot py. Okay, so we want to see this, how to swap two elements. I mean, if I give you two numbers or variables and I want you to swap them, how would you go about it? Is anyone on the call to share with us how they go about swapping two numbers? Ben, fighting, 3. Swapping two numbers. Assuming we had, say, for now, let's say we have A is equal to 10 and B is equal to 20. And what I'm asking you to do is swap the values of A and B. So when you are done, I want B to be equal to 10 whilst A is equal to 20. Okay, so the commonest way that we have found to do this is to create a third variable, and commonly we call it temp, that's the temporary variable, to hold one of them. So we can let temp hold the value at A. That means that now temp is 10. Then we go ahead and say that A, which we have already given, stored its value somewhere, we can then say A is equal to B. So now we have reassigned A. A is now containing what, 20. So in this case, all that we have done here is that temp is equal to 10. Then we come here and we make A to be equal to 20. So when we come down here, we just come and say B is equal to 10, which was 10 already. So now we have B is equal to 10. Okay, so basically that's the commonest way that we find ourselves swapping values. But then in Python, there is a way easier way to do that, and that is through tuples. So now let's use tuples to do that. You have to print something. Okay, so let me print A and B. Okay, that's correct. Print and B. Then I should run this for us to see that it works. 6 word plus X swap. Okay. Swap. Sorry. Swap. Okay. Oh, maybe I should have decorated them. Let's use F strings and say A is equal to A and B is equal to B. Okay, good. Let's run it again. Now A is equal to 20, B is equal to 10. But when we started, A was equal to 10 and B was equal to 20. So we've been able to swap the two of them successfully through this method, which we commonly use almost everywhere. But I'm saying that in Python, we can use tuples to do the swapping easily. So let's try that and see. Use tuples to swap the numbers. You remember that I said tuples basically, if you put them two numbers separated with a comma, even when you have not brought the, you've not brought the parentheses, it's still a tuple. So something like this is still a tuple. So if I do this, it was B A. I want you to pay attention here. Look at it critically. It doesn't make sense to you. This is a tuple that I've created, okay? And this is another tuple that I've created. So essentially, all that I'm saying is that this tuple, I'm assigning this tuple to this tuple. And when you use tuples, okay, or any collection, it compares like, even for assignments, you are assigning based on their position. So here, all that I'm saying is that A should now be equal to this B. Then B should now be equal to A. That's how simple it is. Okay, so let me go here. I want to surprise you. When I print, I go ahead and print this. What do we expect? Yes, this one, someone should mute and tell us. I want to say if you are really following. What do you expect? I said that this is going to swap the numbers. So when we run this program and we print this out, what do we expect? Yes, anyone? Oh, are you not here? Anyone to share with us what you think?
We should swap the values without a temporary variable.
Great. But then what will be the outcome like this? A is equal to what and B is equal to what? What will we be getting?
A should become 10 and B should become 20.
Okay, good. So that's what I wanted us to see. Because originally we started with A is equal to 10, B is equal to 20. But then we still have this function that is swapping there. And currently A is 20. By the time we get here, A is 20 and B is 10. So if we use this, as I said, that is going to be swapping the numbers. So if this is really swapping the numbers, then we should expect that A will now become 10 and B will become 20. So let's go ahead and run this and see. Great. So as you can see from this particular one, okay, from the very first one that we did with the temp variable, we had A is equal to 20 and B is equal to 10. But after that, we came on to use the tuple to swap the data. And now we have A is equal to 10 and B is equal to 20. So in Python, if you are doing Python and you want to swap anything at all, in fact, this is like the easiest way that you can swap your data. And that is with the use of tuples. There are other functions that you can run on tuples, just as we had on list as well. We talked about the max function that returns the maximum number in that collection. We have the main function as well. Then there are other methods that you can also use on tuples. And as I said, I'm not going to go details into them, okay, but let me show you how to have access to those methods. Just like we did the last time, you run how is it called, help on it. So for instance, if I've created a tuple called VB and that VB is made up of this as a tuple, I just run help on VB. And this will give me an idea of the methods that I have that I can use. I said for now, you can be ignoring the underscore methods, and we are going to learn about them later when we learn about classes. But beyond them, okay, so for tuple, we have counts and index. You realize that when we were dealing with list, we had a lot more methods that we could use, but for tuple, we have counts that retain number of occurrence of a value, then index retain the first index of a value. And we actually did this with lists, so not to waste our time on it. That will bring our message on tuple to an end. Now let's jump. We've done almost 1 hour already, seriously. Let's jump to dictionaries. But any questions on tuples as we transition to talk about dictionaries? Dictionaries. Okay, good. So I presume there are no questions. With dictionaries, basically, with all the other two types that we've talked about so far, we've only looked at collection of data, okay? The student marks, and you just gave the marks, and you put just the marks there. But then there's a problem if I want to know in which subject the students actually score that mark. Okay, so for instance, if this particular student, Obed, when we check his scores in mathematics, Obed scored, say, 89, and in science, he scored, say, 59. Okay, and I want to represent this data. With what we have learned so far, I could say scores, and maybe I assign this to be a list, and I'll do 89 and what, 59. That is allowed. Or I could use a tuple because I don't want to change it along the line. So I could use a tuple and make it such. But then, I think we are developing a big program, software, and we're going to be dealing with a lot of data, students' data. And if students have a lot of subjects that they are writing, and you are just saving the data in this form, how will you know that the 89 was for the mathematics and not science, and 59 was for science and not maths? That becomes a bit difficult to track. So that is when dictionaries come, or we find it useful in those scenarios where I need to keep track of what we refer to as a key and a value. So in this case, the subject is a key and the value is the score. Okay, so I will go ahead and say that like this, just as I have here. Mathematics is equal to 89, science is equal to 59. So when we put those type of data together, a number of them together, that is a collection of a key value pair, then we say we have a dictionary. So if you ask me to define a dictionary, I will say a dictionary is basically a collection of what? A collection of key value pairs. Okay, so when we have a lot of these things put together, then we have a dictionary. So now let's look at how do we create a dictionary in Python. Basically, just like any of the other data structures that we've talked about, you have the name of the data structure, or in this sense, like the name of the variable. So how are we going to call this? Let's say we are still calling it scores or scores dictionary, say something of that sort. The difference is that here we use the curly brackets. Okay, so just by doing something of this sort, I've created an empty dictionary. By doing something of this sort, I've created an empty dictionary that I can add data to. So fortunately for us, with dictionaries, they are mutable. Dictionaries are mutable, meaning we can add on to them, we can update them anywhere, anytime that we like. Okay, so let me just go ahead and put the data in it the way would represent mathematics. So it's simply written in this form. The key is written first, but wait, this should be a string. So remember that in Python, strings are supposed to be in the quotation marks. So mathematics, then column 89. So this mathematics, which is a string, is the key, and this number over here is the value. So if we have multiple subjects, we can go ahead and add all of them. Science, the key is science, and the score is 59. So we can have as many as possible, but each key value pair is separated by a comma. So a collection of key value is separated by commas. Okay, respectively separated by commas. So that's basically how we create a dictionary. And one thing we should know is that whatever you are going to use for the key, please pay attention to this. I said the dictionary in a whole is what is mutable, meaning we can change the dictionary. We can change the members of the dictionary, or we can update them, we can delete members of them. But then it is very important to note that the key itself that you're going to use should be immutable. Okay, so whatever you're going to be using for the key, so far we've learned about lists, we've learned about tuples, then we are talking about dictionaries. But remember that we have some primary data types that we've already talked about: strings, we've talked about integers, floats, boolean. Okay, and out of all these things that we have learned, the very one that we have learned that is mutable is what? List. So far, list, we've learned list is mutable. Then we've also learned right now that dictionaries is mutable. So what I'm saying here is that your key cannot be a list. Okay, so pay attention to that. A key in a dictionary. A key in a dictionary cannot be a list or a dictionary itself. Okay. However, the value can be any type of data. The value can be any type of data. Okay, so what I'm saying is that the value that you are going to pass to a given key can be a list, it can be a dictionary, that is, we are going to have a dictionary nested in a dictionary. We could have it as a string, we could have integers, and many more. Any sort of data can be put in there as a value. But when you come to the key itself, we are only allowed to use strings, probably integers, floats, and tuples. Okay, so we'll close the list here. Those are the allowable ones. We can't use list, we can't use dictionary as our keys. Very important. Okay, so how then do we access the data in a dictionary? If now I want to know this student, what did he score for mathematics? Okay, so one thing you should know is that for dictionaries is like the normal dictionary that we know, where if I give you, say, let's take a French to English dictionary, what will you expect? If you have a French no, let me do it the other way around. So English to French dictionary. Okay. So what you basically have is the word in English and its equivalent in French, right? And what this means is that you have a dictionary, like, I mean, this is the key. Sorry, this is the key, and this is the value. So, oh, it is basically the same thing. Any English word that we know in French, maybe say good morning or thank you, any of that. So say thank you. The French will be what? Is it merci, I guess? Okay, so something of this sort. So this is a dictionary where the English version is the key and the French version is what? The value. In fact, it's just like your other dictionary, English dictionary, you have a word and its meaning. Okay, so word is the key, then the meaning is the value. So anytime you want to access something from the dictionary, your interest is in the key. So if it is my normal dictionary, then I'm having a word that I want to know its meaning. Okay, I have a word that I want to know its meaning. Basically, that is what it is. So if you want to access it in Python, you need a name of your dictionary. It is just like in real world life. If you want to find the meaning of a word in a dictionary, which dictionary are you using? Is it Oxford, Macmillan? Which of them are you using? So in Python here, I have defined my own dictionary called source and that of dic. Okay, so I should be able to, no, don't load this. I should be able to go here and say that scores underscore dic, then pass the key to it. So what is the key? In this case, mathematics. So if I do something of this sort, all that I'm saying is that go into this particular dictionary, scores underscore dic, go into that dictionary and get me the value of this key. The key is what? Mathematics. All right, let me go to the terminal, practicalize this. Great, so let's call it mdic is equal to, we say we use the curly bracket, then say maths column 78, sorry, to column 78, then science. Just remember that I have the math and science in quotation marks because they are strings, basically. Say 96, okay? So now I've created a dictionary of my own, and this dictionary is called mtype. So whenever you are not certain, you can just run, you can just run type on it to know the type of the data. So here we have class as dictionary. Okay, so I can go ahead. If I need to access the call for science, all I need to do is call the name of the dictionary. In this case, is mdict. Then the key, what in particular am I looking for? I'm looking for the meaning, because it's a dictionary, that's what I'm saying, meaning. But then I'm looking for the value for which key is signed, and it gives me 96. So that's the easiest way for us to access the data in a dictionary. Okay, get the value from a dictionary. So it's just like we using index, except that with dictionaries, we don't use the index as 0, 1, 2, 3. We rather use their keys. So if you remember, with index, we would have done something like this, the 0. So I brought us something that's in the 0. But in dictionaries, if we need it, we have to know what is the key that we are looking at. Just as if you go into your English dictionary, you should ask yourself, what word am I looking to find the meaning of? Okay, so that is how we assess elements in a dictionary. And we are going to take a look at a few other things that we can do. So apart from using this, I think we could equally use the get method. So please and please again, I don't have to go over all the methods. All you need to do is run the help function on the name of your dictionary, and you get a list of all the methods that are available for your use. Okay, I've been saying this over and over. So there is a method here called get, and let's return the value for key if key is in the dictionary, else default. Okay, so basically we can use the method get. To use the method is the name of the dictionary dot get as the method. Then let's pass signs to it as the key. So if we use the get method, it also returns the value for which key we have provided. Okay, so that is two ways that we can access the members, the values in a dictionary. Any questions? Okay. So if there are no questions, let's proceed to try. Let me create a script using a for loop to get the members in a dictionary. So what will I say? For now, let me call it this. .py. Let's use a for loop. Okay, so we have user main Python 3 using a for loop to access values in a dictionary. Okay, good. So how are we able to do that? Our dictionary was called M. This is equal to, we had maths to be 78, and we had science to be 96. Okay, good. So we'll define a dictionary by writing this line of code. Now, if we want to use a for loop, there is a bit of a trick here. If you want to use a for loop, okay, usually what we do is for the other collections, we just say for, let's say, I in the name of the collection, then you come and say print I. So let me go ahead and do this for you to see for yourself. Okay, let's clear. Goodness, clear. Then make this executable. What's the name for? Okay, then now let's run for did it work or it didn't work? So I guess it didn't work. ch mod plus x. Is it capital or small letter? Okay, good. So initially I was using a capital letter. So I guess it didn't work. Now for okay. All right. So what do we have here? Let's pay attention. It's returning maths and science. That's all that it's written, maths and science. But then our interest is not in the key. If you are using a dictionary, your interest is not in the key. Most it's like saying my interest in the English dictionary is just the word. The dictionary is for you to go and look for the meaning of the word. So mostly when you are using a dictionary, your interest is in the value or the pair, the key and the value. But if you just go ahead and use, if you go ahead and just use I like this, then you have just what? The key. So the other way to go around it, if you remember how we assess the values, you can call this grade, because you know that that is the key that you are going to be using. So if you run this, now you get the values. Okay. The only, we have already talked about using the key on as an index to get the or to access the value in the dictionary. So this is a simple way to do it. There are other ways that we can do it. So let me say this is number one. Let's try another one with the help of what we call the keys method. So I've shown you how to access the keys. We can equally get them. So we have the for subjects, let me use it like that. For subject in mdict.keys. Over here, you are saying that you are interested in the keys. Okay, you are interested in the keys. So basically, it's going to end up giving you something like we had before I change it to this. If you go ahead and print just that. So if I go ahead and I print subjects, then I should expect that. So let me comment this out so that we know what we are printing. Okay, so it prints out the keys for me. That's math and science. Those are just the keys. And it's because I stated that I wanted the keys. There is another method that we can use that is called values. So if you want the values instead, let me make this 3. You could use the values. And for each of these, especially with the keys, for working with the keys, you know that you could have just put the name of the dictionary with the key in square brackets for you to get the values. Okay, but this is also another way that you can get the values. If all you are interested in is the values, then by passing this to the dictionary, as in passing this method or running this method on the dictionary, then you are telling us that I am interested in what the values themselves. Why do I have something as if, oh, okay, I type something here. Correct? Run it. Great, 78 and 96 per the keys. There is another way that we can do, another method that we can use. Please pay attention to all of these things. You may find them useful when you're loading your programs or software. And you can always use the help function to get this information and read on how to use them. Okay, I'm just trying to bring out the important ones. So we can use items. And the difference is that when you use the items method, the items method is going to return a tuple. Remember, we've learned about tuples not long ago. The items is going to return a tuple of what? The key and the value. So it's going to return a tuple of the key and the value. Let me go ahead and run this so that you see what I'm talking about. So when we run this time round, it gives us a tuple. As you can see, we have maths 78. This in the form of a tuple. Right now you understand it. And science 96. So if you want to have access to the whole item, that's the key and the value, and the easiest way is to use the dot item expected. Okay, and another simple way, so maybe I should make that number 5. Another simple way is to do this, make this 5, comment this out. Another simple way is to create a tuple here. So instead of subject and what score, you remember that the item is going to always return a tuple, and we have what one, the set and the score. So by doing this, all that we are saying is that the tuple that is going to be returned, you are interested in putting the scores in the subject in this variable and the score in this variable. So if I go ahead and I print right now, it's just going to print the subject alone for me, because that's all that I'm printing here. If I do subject, maybe let me use the and say subject is equal to, then put this in curly brackets, and score is equal to, then put this also in curly bracket. Great. All right, so if you pay attention to what we have here, we are trying to tease out, this is going to return a tuple, and we are trying to tease out the tuple that is going to return the members of that tuple, and we are assigning subject to the first one, then score to the second one. So if we go ahead and print it, we should have something like subject is equal to the subject and score is equal to the related score. So let me go ahead and print this. As you can see, subject is maths and score is 78. Subject is what? Science, score is 96. So this is how you go about using the for loop to run through a dictionary to get the members, use them for whatever you want to use them for, and things. I think one thing that I didn't talk about is updating the members of a tuple. So of a dictionary, sorry. Unlike tuples, we can update members of a dictionary. We've mentioned that a dictionary is mutable. So that means that we can easily update them. We can easily add on to the dictionary. And for now, we know that the dictionary is defined as something of this sort. Say, let me say A is 56 and B is 79. C, okay. When I finish, maybe I should develop some. All right, let's see. A is 56, B is 67. If I want to add C to it, simple thing to do, just come here and create a new one. Say dictionary with the index C, which is the key. I'm using the key C, is equal to what value? Say 89. Since it doesn't already exist, now it's going to be put into your dictionary. Once the key doesn't already exist, it is going to be created or added to your dictionary. So now you can see that C has been added. But if I go ahead and I do same with A, already A exists. So now I'm changing A to 100. And if I run M8, you see that A has become 100. So that is how we update the data in our program. In fact, we can use this to collect, let's say, I want a BMI calculator. I want to develop a BMI calculator. I can use this to collect, say, weights. Then you put your weight here, maybe weight in a particular words units. So we say kilogram. Then the next one will be your height and height. So say height in a particular unit, maybe meters, 1.72, something of this sort, and you go ahead and tease out the individual values to calculate your PMI. So that should be an assignment. I think when we're doing C programming, I wrote a C program to be doing the PMI calculation. So you can take it upon yourself using dictionaries, create a program that will be calculating the PMI of anyone. So the person enters their weight and they enter their height. You put those data that you collect into a dictionary. Then you take, probably with a for loop, you take the weight and the height, calculate the PMI, then display the value to the person. So those are some of the ways that you can practice with what you have. There is a method called update. So that you can also use to update elements in a dictionary, but then I'm not going to talk about it. So do all to check up on it. In fact, there are a lot of other methods that I should probably, if I want to talk about it, we are not going to leave here. There are quite a number of them. So we could have pop as a method with dictionaries. When we're dealing with tuples, you realize I didn't make mention of pop, even though I did mention pop when we're doing lists. The difference is that you are using pop to delete an element. You said tuples, you can't delete an element, so there is no pop in tuples. Dictionaries, we can delete an element so far as we have a key. All you need is to pass the key to the pop method and it's going to delete it for you. So for our PMI dictionary, if I do pop, then I pass weight to it, it's going to end up deleting weight for me. But then you should know that pop also returns whatever data is deleted. So now if I run BMI, you see that weight is no longer in the BMI dictionary. There is another method called pop item, and pop item basically deletes or pops the very last member in a dictionary. So let me use mdates.pop item. If I use mdates.pop item, it's going to return the last thing. So the last one here is what? C, which is 89. That means it has now deleted it from our dictionary. So if you run the dictionary now has only what? A and B. So there are quite a number of them. There is a clear method which will render your dictionary empty. So it will clear every member of the dictionary, leaving it empty. And in the same way, we have been using the len function on the other data types. You can equally use len function on dictionaries to get the number of elements in a dictionary. Any questions on that? Otherwise, I have to move on to sets. Then we'll finalize it with sets. Any questions on dictionaries? I'm getting tired. Okay, so let's start looking at sets. When we start talking about sets, it's really not a new thing because almost every one of us here did some form of basic mathematics. And we learned about sets. Set is a collection of data, right? But then it's a collection of unique data, okay? Where unique means that you can't have duplicates, basically. So from primary school, from junior high school, you've learned about sets, a collection of data. What makes set peculiar in our case is that it contains only unique data. So I can't have a set that has more than, the same member, the same element appearing in that collection more than once. That is not possible. Okay, so set is a collection of unique data, and unfortunately, so let's try and bring out the attributes that we've been defining. Unfortunately, the sets are not they are not indexable. So maybe I should write non-indexable. I hope that is a term. Not indexable. That means that we can use index, unlike the others that we've discussed. List, we said we could use the index to access it. Tuples, we could use the index to access it. With dictionaries, we could use the keys as the index sort of to access the values. But with sets, we can't access the values with the index. And one of the major reasons is that with sets, they are not ordered. Okay, unlike the others where the order of appearance was important, with sets they are not ordered. In fact, I should have said it about dictionaries. So if you are watching, say, some tutorials on dictionaries, some of them will say that dictionaries too are not ordered. But the truth is that prior to, I think, Python version 3.6, dictionaries were not ordered. So when you print it, you could print in any order. But from version 3.6 and upwards, the dictionaries are now ordered. So they will always print in a particular order. So far, with respect to the 4 data structures that we are talking about, the inbuilt data structures we are talking about, it is sets that is what's not indexable and not ordered. They are not in any particular order. But set 2 are heterogeneous, meaning they can contain data of different types. Heterogeneous. Okay. Heterogeneous. Okay. So they are also heterogeneous. And when you start talking about sets, you're like, good, we understand that they are unique. So anytime we want to use a data, a set of data that we don't want any form of repetition, then the easiest way is to use a set, or the best data type to use is a set. But from your basic mathematics too, you realize that whenever you have a set, there are a lot of operations that you can do on sets. In fact, the attribute I didn't add that is immutable. Immutable. So you can't change the members of a set. Once it is set, it is set. So when we talked about tuples, you understood when I meant immutable. Same thing in set. Once we create the set. Okay. So let me slow down here. I was going to run through, but let me slow down here. With the immutable thing, some people may end up getting confused. So what you should understand about sets is that the elements of a set, okay, elements of a set are not mutable. That's immutable. But the set itself, the whole set itself is mutable. So if I don't, if I refuse to mention this, you may find something and you start questioning yourself. Didn't we say the set is non-mutable? Okay, so what is the difference? The difference is that when you pick a set, okay, so now let me quickly jump to how we create a set. A set, you remember this symbol, you just use it to define a dictionary. But a set is basically like that. Say, let me call it my set. It's equal to, use the curly bracket. So far as you don't provide key value pair, then it is a set. If it is a key value pair, say I do A, then A. This is a dictionary. But if I go ahead and I do just 3, this is a set. Okay, so I could have 4, 5, say 6, and 4. I intentionally wrote this for just to tell you that we can't have something of this sort. Okay, we can't have 4 here and 4 there. That is wrong. A set can have duplicates. It's unique. The members are unique. So this is a set. Okay. So what we are saying is that now you can't come and say you want to change this member. That is no longer 3. It has to be 13 instead. No, that's not. It's not allowed. You can't come and delete 4 out of 8. You can come and update for something else, okay? But then the whole set in itself is mutable because I can add on to the set. So if I want, I can add new elements to the set. Okay, so in essence, we are saying that once you have a member, sorry, we can't have 6 no more. Once we have a member in the set, that member is immutable. So this particular one is immutable, this is immutable, this is immutable. But the set as a whole is mutable. We can delete the set, we can update the set, okay? So that's very important. And just as we have done with all the others, when we create a set, we can easily get the methods that we can run on a set. So let me close this in clear and open it again. Create a set. My set is equal to 3, 4, 6. So let me intentionally write another 6 and see what we get. Hit enter, then print my set. You see what happened? Even though I created it by adding 3, 4, 6, 6, that's like 4 elements, I end up getting only 3 elements because the set is unique. So at the end of the day, even though I wrote this, that's not what was stored in memory. In the computer's memory, 6 can only appear once if it is a set. If you are going to deal with data that is not unique and data that you expect to duplicate, then you should be using more of a list, okay, and not a set. Once you are using a set, we expect you not to have duplicates in there. So if I run help function on my set, then we get the methods that we can use on it. Let me scroll down. For now, I keep saying we should ignore this one. So here we can see we have an add method. When we were looking at tuples, if you paid attention, we said tuples are immutable, and there was no add method. We couldn't add to a tuple. But then with a set, we can add an element to a set using the add elements, the add method. So that is where the difference comes in. When I say that the members or the items of the set are immutable, but the set in a whole is mutable because we can add members to the set, we can clear all the members in the set. Okay, so that's basically some of the methods that we have: difference, update, discard, a lot of these. So at your own convenient time, try playing around with these ones. In fact, if you start playing around with them, try to get a full idea of what is possible and what is not possible before you start developing bigger projects. Because by the time you start developing bigger projects, you may want to do something and you have no idea of what you can do or what is possible. And that's a problem. You spend a lot of time doing research. But if you know for now that, oh, we could actually check if, let's say, using this method, it says you can report whether another set contains this set. So for instance, you are developing an application, you have collected data in, let's say, a set somewhere, a bigger one, okay, and you want to see that the data that your end user has supplied, you want to see if this data actually belongs to what you already have. So all that I need to do is convert that data I have into a set and check if this set is a subset of the other. Okay, by not knowing this, you now, like, in fact, when you go online to go and search, you don't even know where to start from. Okay, so for now, try playing around with all these, the various ones, what does POP do, and all of these ones. I'm going to talk about a few of them, which is like a bit important. In fact, when you are talking about sets, I believe that the more focus should be on the various operations that you can perform on a set. So let me go and take a look at that so that if I end it anytime soon, we'll still have done something. So basically, from basic mathematics, we learned that we can talk about union, we can talk about intersection, right? Intersection. Okay, we can talk about intersection. We can talk about what else? Union, intersection. For mathematics, what and what did we learn? Okay, so you let me focus on this one. We have union, we have intersection, we can talk about difference. Then the last one I want to talk about is the symmetrical difference. So we can also talk about symmetrical difference. And let me try explaining each of them. At least for the union and the intersection, I believe that almost everyone would understand. Union is like a combination of two or more sets, like you are looking at the union. So basically, in mathematics, when we talk about the union, we used to use this operation symbol to represent union. In Python, if you have created a set, so now let me create a second set called, say, your set. And let me define members of your set. 6, 8, 10, 12, 4, and 16. Okay, so now I have two sets, my set and your set. If I go ahead and I want the union between these two, what I can do is say my set dot union. Remember, the union is a method, and if you want to use a method on any data structure, you do dot then the name of the method plus the parentheses, as we have been doing with the other methods. Okay, so if I do my set dot union, then I pass your set. That's the other set that I want to check. So this is going to return the union of this set and that set. And union basically means that like everything in this set and that set, we are putting them together. Okay, so in mathematics, we sometimes used to call union as or. If you remember your mathematics, we used to call it as or. And in programming, bear with me that we represent or with this pipe sign. Okay, so instead of writing my set dot union your set, we could equally do my set, then we pipe, then your set. Okay, so this is like saying my set or your set, and it's going to retain the union of it. Let me go back to the terminal. Okay, my set is here. Let's create your set. So your set is equal to 6, 6, 8, and 12. All right. Now what I was teaching over there is, let me use my set dot union. Then I pass your set to it. Okay. When I run this, see what it returns for me. A combination of this and that. I mean, set and your set. But remember that a set is unique, so we can't have duplicate values. So when we are joining them together, 6 is here, 6 is here, but we are going to maintain only 1 6. So we have 3, 4, 6, 10, 8, and 12. So that's a combination. And I said that we could equally do my set then or your 6. And they should also give us the same result. So it's one way to find the union. Okay, please think deep about these things. They can be very practical. You have two sets of data that you've been given. You want to see or you want to put them together, but you don't want any duplicates in them. Just convert those data into sets, then use union to put all the data together. Okay, so when you are developing an application, there may come a time that you need something of that sort. That is for union. When we talk about intersection basically refers to what is here and here. So if we are looking for intersection between these two sets, then we are looking at what is in set, my set, what is also in your set. If we have something that's present in both of them, then that becomes the intersection. So we can do my set dot intersection. Then inside here we have your set. If I run this, it returns 6. because it's only 6 that is both in my set and your set. So that is one way to find. Okay, so that true list that you've been given to work on, you want to see if there is anything that is common. Do you have any common members in those data sets that you've been given? Then you can convert those data sets into sets and use the intersection method on them to check if there are possible duplicates in there. Okay, but intersection, as we have said, is and. It's here and there. It's here and there. That means that we can equally use the and symbol, which is this. So my set and your set, to also achieve the same result as intersection. Okay, the difference. With the difference, let me go ahead and run it for you to see, and then I'll use the outcome to explain it to you. So we can have this. So there are two different types. I mean, there are two main types. We have the difference, then we have the symmetrical difference. But that's all. Let me just help you out by going to this help to show you what they wrote for you. So when you come to difference, this is difference. It says it returns the difference of two or more sets as a new set. Pay attention to this part. So the difference, what is not here and not there. But then all elements that are in this set, but not the others. So that means that even though you are looking at the difference, if there is any element that is repeating, it will be ignored. All elements that are in this set, but not the others. Okay, so let's see. Let's go back and run my set dot difference. My set dot difference. Difference, right? Then your set. Run this, and we are getting 3 and 4. So this is my set, and this is your set. So what do we have? You're taking, pay attention, this particular set. So what is in this set that is not in this set? 6 is here, so obviously that will be ignored. But then you realize that 8 and 12 were also ignored. Why? Because difference is focusing on just this particular set. Okay, so what is inside this set, which is not inside this set? How we can see that? For the difference as method, what is, you are saying difference is this. So what is inside this set that is not inside this set? Okay, another way to check for difference instead of using that difference method is using the subtraction symbol. So we can do this, my set minus your set, and we get 3, 4. This means that if I do your set minus my set, we are going to get a different outcome. The reason being that our focus now is on your set. Okay, so we are looking at what is inside your set, which is not inside this. But then if we want to see anything that isn't like a duplicate in them, I mean, what is unique about this set and unique about, okay, that is what we refer to as the symmetrical difference. So let's go back to the methods that are available. We've looked at difference, symmetrical difference. It says it returns the symmetrical difference of two sets as a new set. Pay attention to this. All elements that are in exactly one of the sets. Okay, so they are not in both sets. So let's go ahead and do that. That you would have to write it as such. So my set dot symmetrical, hope I get the spelling right, difference, then your set. So, spelling, did you mean symmetric? Oh, symmetric difference. Sorry, I've been saying it the wrong way all this while. Symmetric difference. my set dot symmetric underscore difference. I'm getting tired, I can see. Your sets. Okay. Then we run this, and this time around we are getting 3, 4, which is like the unique member of my set. Okay, then H12, which is the unique member of your set. Okay, so the other way that we do the symmetric difference is using the exclusive OR, which is this symbol on my keyboard is right above number 6. Okay, my set and your set. That will also give us an outcome. So you realize that there are quite a number of useful methods that we can apply on sets, and they have a number of use cases. Anytime you want, you want to save data that is unique, you can do that. And in fact, if you have a list, so let me create a list and call it my list. Oh, right. My list is equal to 1, 2, 3, 2, 1, 5. This is acceptable as a list, okay? So if I've given you this sort of list, and I want you to do something with each number that appears here, you realize that are appearing here are 1, 2, 3, and 5. Okay, basically 2 and 1 were repeated, but I want you to take a number. So my interest is not like each member. There are a lot of times that you may need to do something like that. So in this case, your interest is the number. So you want unique numbers in there. If you happen to have a case like this where you have to do something with the numbers that are here, okay, what you need to do is you need to convert your list to a set, and you use the set function. Say set, then you convert it to a set. So you realize here I had how many elements? 1, 2, 3, 4, 5, 6 elements. But when I converted it, I now have 1, 2, 3, 4 elements because it has removed the duplicate out of it. So all I'm trying to bring to your attention is that they have a lot of use cases for it. Anytime you are trying to deal with unique data or investigate the presence or absence of something in the data, sometimes or most times sets can be a choice. Just have to learn about the various methods that are available, then see when you can use it and when you cannot use it. Then I'm coming to end. If you have any questions, just go ahead and ask questions. Then there is one thing that I want you to find out on, that is what we call a frozen set. A frozen set. So read on frozen sets. I think I'm tired at this point. Yes, any questions? Otherwise, we have come to an end. Any questions? Okay. 1, 2, 3, 4, and 5. All right. Thank you all so much for your time. I really appreciate it. And hopefully we'll meet again for functions in Python. I'll see you when we meet. Bye-bye.
Thank you, Barry.